Okay, so today we are moving into the second day, which is just applications. So it's just a short little quick practice with applications. If a sailing club has planned a triangular race course, which is often the case in sailing, as shown in the diagram, how long is the leg of the race along BC? BC. How many degrees must competitors turn at point C and round the length to the nearest tenth and the angle measure to the nearest degree? Come back and check out your answer here. Okay, so the first thing we want to find is BC, right? BC. And we do have this angle here, 45 degrees. We have no other angle, so which of the laws are we going to use? Law of cosine, right? So to find BC, we know that it squared equals the sum of these other two sides, the adjacent sides, right? Minus 2 times what? You remember? These two sides, AB, right? And times the cosine of 45. So we just have to use our law of cosines. Substitute the known values. And this will give us, again, c squared. So don't forget, we've got to ultimately take the square root, right? So we simplify there and find the square root, and it's about 2.8 miles. Is that what you got? Good for you. Good for you. Okay, so we found BC. We now have BC. We could fill that in, which is 2.8. So let me grab a little something and write 2.8 miles. Whoops, 2.8. Okay, here. So we're being asked now to find what is the number of degrees they would have to turn at point C. So what could we use here? What are you thinking? Good, the law of sines, right? Because we have 45 and its opposite side, 2.8. So go ahead and try that, come back and check. So what would we do? Sine of A over BC equals sine of C over AB. So we go ahead and substitute the known values, and we will bring the 3.9 up, right? And we're going to take the inverse of sine C, right? The inverse of this in order to find the actual angle C. So if sine C equals that, again, we're going to take the inverse of that to get the measure of 83 degrees. Is that what you got? Outstanding, good job. Okay, what if we have the Leaning Tower of Pisa and an engineer suggests to attach a cable to the top of the tower to a point 31 meters from the base. 31 meters from the base. That's not what this is showing, is it? Why does the book do this to us? How long would this cable be? Which is AC, right? And what angle would it make with the ground? Okay, let me tell you that this missing side here is not 31. This side here is 56. And then we know that the cable is attached 31 meters. So this is actually the 31 here. Okay, so now we have two sides, 31 and 56, and we have an angle of 100 degrees. So how long is the cable AC? Now we have the information we need, okay? So we're going to say that this side is the unknown. Let's say it's X, right? Okay, how do we do that? Go ahead and pause the video and come back and check. Okay, so AC squared or X squared equals the two known sides squared, the sum of them, minus 2 times each of those sides times the cosine of B, which is 100 degrees, right? So substitute your known values and go ahead and you multiplied, right? And then you need to find the square root, something slightly under 7, right? Because the square root of 49 is 7, and of course we've got to move our decimal over because this is thousands. So something under 70 is 68.6 meters. Very good. Awesome job. So we're going to go straight to the part 2 lesson quiz and see if you can find A, And number 4, pause the video, come back. And A is 477.2. Find C. C is 21.6. Find measurement of angle A, which is 115 degrees. An observer in a tower sees a fire 1,554 feet away at an angle of depression of 28 degrees. So remember, that's the angle from the horizontal, right? To the nearest foot, how far is the fire from an observer in tower B? Okay, and to the nearest degree, what is the angle of depression from tower B to the fire? So go ahead, pause the video, and see what you can find. Okay, so once again, you had to use the law of cosines to find this side, right? And so when you did, you got, here it is, 1,212 feet. And then you would use your law of sines to find the angle B, which is the angle of depression from tower B, and that should be 37 degrees. Woohoo! Good job. And there you go. Have a good day.